Hello and welcome to One on One. I'm Vernon Ramazan. I'm very pleased to say my guest today is Dr. Sanjay Bahadoorsingh, who is Trinidad and Tobago Section Chair of the IEEE and, of course, UWE Lecturer, Department of Electrical and Computer Engineering. Welcome.
Thank you, Vernon.
Very much, Sanjay. Thank you for being here. Now, you deal in fields that I have no clue about whatsoever, and you've got an event coming up on Thursday from 2 to 4 at UWE, where you're looking at the idea of smart grids.
Yes.
I think we should start this conversation by asking, what the heck is a smart grid?
That's a good question, very good question. Well, a smart grid means different things to many different people. And what we would have as a smart grid now in Trinidad and Tobago satisfies the needs for electrical power distribution to our consumers. But the grid of tomorrow is one that's going to change. We have bidirectional flow of information and power. It's going to change the way we use energy. It's going to change the way it costs. It's going to be clean. It's going to ensure that it's more efficient. And more importantly, we're going to be moving towards the next step in terms of energy consumption patterns. We're going to be influenced by the pricing structure. We're going to be influenced by our daily routines based on what the appliances that are now smart can tell us. This is the time when we should do this activity. So, smart grid in a nutshell, it's going to be an evolution that is happening now. It's a revolution, I should say. It's happening now. And it's about information, it's about energy flows, and it's going to include ICT. The ICT in this case will be digital communication. This communication technology is going to influence the way in which we can therefore utilize the energy. It sends control signals from the devices all the way from the consumer level back to the utility. So it gives us an idea of how we are using the energy, when we should be using energy, and this will just continue to improve, making the grid stronger. It's going to be self-healing. Self-healing in terms of there's a disturbance, it will be able to rectify itself.
So like the internet to a certain extent.
Well, it is
similar. Able to route around problems.
Similar, yeah. You can route around problems, give you another automated and optimized part, if you like, to ensure that the lights stay on, because we all know the lights go out, we have a problem.
Provided you pay the bill, of course.
Well, provided you pay the bill, which is also another point, Vernon. Our bills are very cheap in Trinidad and Tobago.
Which we don't realize, actually.
We don't fully appreciate. Based on the Caribbean, we are the cheapest. And in fact, when you look at our price per kilowatt hour, we're blessed in Trinidad and Tobago. We're very blessed. So part of the smart grid is ensuring that we utilize that energy in the most efficient and most appropriate way to save money, even though we're blessed with
well, that is one of the problems, isn't it? Because one of the impetuses to actually conserve and to be efficient in how we use things is to realize the value of it.
Correct.
Like, for example, in Europe, where power is expensive, or even in some of the Caribbean, and Bonaire and Aruba, for example, where they use desal, and that's also tied together. People are very aware of how they use power. Here, we just kind of use it willy-nilly because it's not costing that much.
Yeah, that's really a challenge for us. And before you can really say that you're actually utilizing all your power, you need to take stock and determine if you're utilizing it effectively. Energy conservation can really give you that. And if you look at most energy audits globally, they're really geared to ensuring that we use the energy that we're supposed to use and there's minimal wastage. So before we could even move towards integrating new forms of power into the grid, are we fully utilize the power that we have now? Therefore, we could determine if, in fact, we're wasting money. And apart from that too, what about carbon reduction, carbon emissions? We want to reduce those carbon emissions. If we can conserve our energy, we actually be doing world of good for the environment.
Now, in terms of where we are now, as opposed to where you see us being in, I don't know, 10, 20 years, we're kind of in a dumb grid now, are we?
I wouldn't say we're dumb. I say that it's all relative, right? We're smart because it satisfies the objectives. All lights are on. And being the most developed grid in the Caribbean, we are blessed that we have not only cheap forms of, but a very reliable form of energy. People don't often realize that. But to say we're dumb, I think that's a bit harsh.
But in terms of the grid itself, it's an aging grid, isn't it?
It is very much so aging. The infrastructure is very old, and we're constantly evolving. So we may have legacy equipment there that needs to be updated. However, moving towards a smart grid, it's not a forklift movement, as you would say. It's going to have to be very incremental. So we're going to take bit by bit, and perhaps that's the most sensible approach that we can take from a utility level, a national level, all the way to the consumer level. And if we look at this in a very strategic fashion, we could develop microgrids. Microgrids are basically pockets which are localized communities, facilities that we can have the added infrastructure of terming it smart. where we optimize our energy usage. We ensure that we are energy efficient. We ensure that we are using the energy as we're supposed to use. And then that translates into reduction on our bill.
Well, if we're talking about micro-communities, it seems that you would be a good place to start.
That is exactly what we have planned as part of this project. We want to be able to showcase what we can do on a very small scale where we can have enough control. So we're looking at perhaps by next year to have some small initiative that will showcase what we can do on a microgrid level.
Would legislation have to be enacted to sort of change the existing laws? Because I know basically right now the power distribution is sort of set that it's T and Tech and power production is power gen, for example. Would that have to be sort of changed in some way to allow?
Yes, it would. It would require a significant restructuring. And one of the challenges associated with that restructuring is we need to be able to prepare for what happens, not next year, not after in 10 to 15 years, because if we have to move to a structure that's dynamic in terms of its pricing, which is called dynamic tariffs, it means that the consumer has to be aware of what price they're paying for electricity at that particular instant. Based on the quantity of electricity that they consume, they'll be billed appropriately. So, structure is required both on the legislation as well as from a regulation perspective.
Because in fact, you'd be looking at, for example, the times of heaviest demand, power would cost more, wouldn't it?
Correct. Because if you look
to
at
give you an incentive to sort of use power off peak.
And what that does, it's called peak shaving, where we don't have these huge peaks anymore. What we'll have is a levelized low duration curve. That's beneficial for us. Why? Because it means that we'll be able to generate power more efficiently. Normally, when you have power production at its peak, it's more expensive forms of generation. So if we can levelize it, it means we're actually transitioning towards a more economical approach to power generation.
How do you do that? Because I mean, presumably the peak times are based on the fact that that's when people are using power because they need to use power.
Correct.
So for example, in the morning when everybody's getting ready for work, you'd have hot water heaters going, you'd have air conditioners going, whatever you have to sort of get people on their way. So how do you push that off peak?
Well, there may be some unavoidable peaks because of requirements that you have to fulfill those obligations. However, there may be some instances where we can reduce that peak by a percentage. Just to put things in perspective, recent reports I read suggested that anywhere between 13 to 24% of that peak can be reduced by employing smart grid technologies. Now, think about it in terms, those percentages based on the absolute numbers put us at a very huge chunk of our electrical energy. So if that power is reduced and shifted elsewhere, our curve will actually look less steep. So it is beneficial, and it's really geared based on the pricing structure. So we need to get there. So as long as that pricing structure is there, it may incentivize the consumers to say, well, I actually can delay this activity. I need to do what I have to do, but based on the pricing structure, it's actually beneficial for me and my wallet to do it later.
Is there sort of a general interest amongst stakeholders to have this sort of technology upgraded? I mean, does the average consumer know or care, and do power companies know or care about the possibilities?
Yes and no. And one of the challenges we face is based on the cost of electricity, which we alluded to earlier. If the cost is so low for us that we don't have an appreciation of our electricity, then we won't be able to appreciate what this advanced infrastructure can bring to us. However, it doesn't mean that we won't be able to save from it. We have the opportunity to reduce our carbon footprint. If we look at those statistics that put Trinidad and Tobago per capita as one of the highest emitters of carbon based on the population size, it means that we have the opportunity to make a significant dent into that value. Relatively speaking, we're less than 0.2% globally. That means that whatever we do, we may not influence the global framework. However, we have a chance to show that we're environmentally conscious and we're active towards reducing that figure. So while our costs may not be a driver as yet, we definitely have other drivers. And I think that as time goes on, everything is going to fall into place because we need to be positioning ourselves to be a 21st century grid.
Now, I know most things are determined by the market in this world that we know. So to me, it seems that we have the opportunity to either sit on the aging infrastructure that we have, because it seems to be working pretty well so far, or presumably there's a cost to this upgrading. We put money into the system with the hope of some future return, whether it's a nice moral cause or reducing carbon. What's the incentive then, based on the market, to spend money on something that's already working?
I like your trend of thought, because if it ain't broken, don't fix it. All right. But what we're looking at is an aging infrastructure, yes, and there's concern that when our consumer patterns change based on the devices we plug in. For instance, in a few years' time, when the advent of the electric vehicle comes into Trinidad and Tobago, we're going to have significant changes in the load flow pattern. It means that our infrastructure will see a different form of its operation. And one of the challenges associated with that is it now ages differently. We have no idea of the predictive maintenance and how it's going to change in terms of the longevity of that particular piece of equipment. So if we take a step back, that piece of kit that's in the system for 40 plus years, it will eventually give one day. And it may give simply because the operation environment has changed. So we need to be in a position to address that before it happens, because we all know when lights go out in this country and anywhere in the world, it's a calamity.
But we can still sort of patch things as they fall apart, can't we?
Well, we can patch, but
I mean, I don't want to seem like a Luddite, but I mean, you can keep the thing working with enough manpower.
Yeah, you can keep it working, but when it goes down, it costs billions of dollars. It costs billions of dollars. And the reliability that we need, particularly in this country, we have a very booming industrial estate. We need to keep our lights on. We can't afford to have that. At different levels in the society, people have different needs for electricity, and the cost of electricity varies. But in any developing society, electricity is critical, and it has often been linked to economic development. So it's really important for us to keep those lights on. And of course, it's not at all costs, but relatively speaking, within reason, and what we can compromise based on the legacy equipment transitioning incrementally to ensure that we have the best supply possible for the application at hand.
So it is possible to retrofit, to some extent, the existing grid?
Yes, we can. We can definitely retrofit. Retrofitting is challenging. It's much more challenging than if you had to install a new electrical system, because you're looking at the legacy equipment communicating with now new equipment. And while the technology may be old, it's very much functional, but that challenge remains. But it's also a booming market as well, because it gives a lot of software developers, a lot of entrepreneurs the ability to retrofit, redesign, and ensure that we could use cloud computing to store the data, use applications that are in the cloud to help us control, store that data, we manipulate, do the analytics. So we're in a better position, much relative to where we were a few years ago because of that. So while legacy retrofitting is challenging, it's not impossible.
I guess the challenge of mixing the digital and the analog world.
It continues to be.
There's a problem at some point always. Are there any countries that currently employ smart grids?
Oh yes, we're looking at more developed countries. I mean, we could easily look to our North American friends in the US. We can look at Europe, and there's some degree of smart. That's why I said earlier, smart means different things to many different people. And if you would, I read a survey somewhere that talked about the American population and what they were aware of in terms of smart grid. Not everyone knows about it. Not everyone is aware of the functionality and the benefits of the smart grid. So therefore, by naturally, not everybody will be interested in it because it doesn't immediately impact on them. But it's happening, and it's happening across the globe. A lot of these developing countries are moving towards ensuring that their grid is full control. There's automation. It's what we call self-restorative. And most importantly, we're going to keep the lights on.
Well, I know the North Americans, certainly the Americans themselves, view now electricity and their grid as part of national security, of homeland security. Because we've seen examples in the past where their smart grid wasn't so smart, and one power station went out somewhere in Quebec or somewhere, and the entire eastern seaboard goes out.
So that was in 2003. Right. So that blackout was a very famous blackout. And when you look at the post-mortem for all these blackouts, it underscores that we need to have a very strong network, and strong network in terms of its power system resilience, as well as to prevent cyber attack. Because communication has often been one of the challenges. Not having real-time communication was one of the failures for that particular incident you spoke about. Now, while that communication was not really timely, we also have to ensure that it's secure. So this is where the cyber aspect comes in, and there's a lot of standard development going in to ensuring that there's a framework for cyber system security. Because I read on an article in the press recently that speaks about these hackers evolving faster than the actual software developers.
Yeah.
So we need to keep one step of the game, and that's definitely one thing that we have to look at.
Because even so, that with the Iranian nuclear program, that was hacked into and sort of delayed for quite a while.
Exactly. And you have the potential here where these hackers can extort money. They hold you at ransom until you pay them to give them back your power supply.
One thing that you mentioned very early on in our discussion was bidirectional.
Yes.
I guess that's the idea of feeding power back into the grid based on
Yes.
some sort of home generating capacity, whether it's solar or wind or whatever. Is that what you're
Correct.
talking about?
So bidirectional, we have flow of power and data. So if we look at the data will tell us basically, this is how much power I'm using now. This is the price of power. So we have that exchange of information. I can make the conscious decision if I want to execute my activity and use that energy. In terms of power flow now, we have a situation where we may have distributed generation, whether it be from a solar panel on the rooftops, from the nearby wind generator. We have this excess energy that may be fed back into the grid. Of course, it's not so easy. There's a lot of technical studies required, and most people need to appreciate that that doesn't just happen overnight. But yes, bidirectional, we can facilitate that. And think about it in the future, when electric cars are here. That's a huge source of power that's just sitting there. In times of low peak, electric vehicles may be able to supply power to the grid.
How would they supply power?
Because the battery's charged.
So it can actually push back in once
so
it's on peak period.
Correct. It's called grid to vehicle, G2V. So
do you ever think we're getting to the point where we're going to have any significant number of electrical vehicles?
Oh yes, we're going to get there. We're going to get there.
I know you seem excited about it, but I just have my doubts because they're so expensive at this point compared.
They're expensive, yes, but price is only going to go down. When we consider what's
But we're living in a country with subsidized gas.
Yes, we are. But if there's the opportunity to have a shift from the gas and ensure that it's cheaper, it's much cheaper for us to have power being produced and to charge these batteries than to go fill up in the gas station. No more will be a queue for the gas station, Vernon. Your gas station will be in your garage. It may be at your home, at your work, at play.
This fuel is being burned to produce the electricity, though.
But it's a much more cleaner fuel as it stands right now.
Although I remember reading somewhere that, in fact, when you actually break down an electric vehicle, it actually has a worse environmental impact, a Prius, for example, than a regular car in terms of its impact on the environment, because of the way the batteries are manufactured, the method of making the batteries, the fact that they're shipped halfway around the world to be put together. So that technology has to improve, doesn't it?
Correct. That has to improve, and the batteries remain one of the key issues in terms of how do we dispose of these batteries after. Of course, the movement of products across the globe, whatever fuel source they're using, is obviously going to impact on the carbon footprint. So those aspects are going to have to be considered, but collectively what we're looking at is a paradigm shift in transportation. Transportation will be electrified. And as Trinidad and Tobago is strategically placed in terms of its electrical grid, we're going to be pioneering a way in this in the future.
Now, you're the engineer here, so Sanjay, explain to me how data is sort of carried on the current electrical cabling that we have. Are you looking at a parallel cable, or is it actually going through the same wires?
No, well, we have different forms of communication. You have everything from a power line carrier, which is a physical infrastructure, all the way to wireless technology. Maybe radio frequency, maybe other protocols.
So your fridge, for example, let's use a fridge. Your fridge can be would use Wi-Fi to send its information back to you?
It can. Your fridge may be fitted with a Wi-Fi module that can then coordinate with some device at home. So you can have this energy dashboard, if you like, at home that gives you an indication of what your energy consumption is. Now, we have in Trinidad and Tobago the AMI, which is the Advanced Metering Infrastructure. What that is, it's a smart meter that can basically tell us how we're using energy, and that feeds back now to the utility. So while the appliances in your home may have some individual capability of logging energy, it's then cumulatively dispatched to the utility, who can then perform some sort of analytical function and tell us, okay, well, this is how much energy we're using from this particular part of the grid. Do we need to have some corrective action because there may be a threat imminent for an overload? That's the sort of communication that we're looking at. So there are many different forms, locally as well as from what I would say is a more node-connected system.
This is all sort of visionary thinking, isn't it?
Yeah.
Is it pragmatic thinking? I mean, because I know you're coming from an academic background, and therefore by nature you have to look forward to where we should be or could be. But I mean, in terms of us actually getting there, have we made even slight baby steps in that direction yet?
Well, then we're going to get there. We have to be very positive.
Does that mean
about
we've done
this.
anything yet, or?
Well, yes, we have. We
have, okay.
Yeah, we've got the EMI infrastructure in place. That system is basically the vertebra moving forward, because that acts as a focal point for data concentration. How we treat with that data, we still need to find an effective way of dealing with that, because we have all this data collecting. We need to be able to massage that data into something meaningful so that we
So
can...
right now, all it does is tell T and Tech,
Yeah.
power's gone out there.
Yeah.
For example, there's a blackout, send a crew.
It helps. So that's one form of ensuring that our reactive nature is improved. But there are lots more that we can do with that data to ensure that the behavioral patterns are influenced positively. So we're making new strides, and we're going to reach there. We're going to get there. Our oil reserves, and if you look at it, our natural gas reserves, they're not infinite. They're finite. Mm-hmm. We need to be taking some conscious actions about how we position ourselves for power in the next few years.
So the event on Thursday, what's going to be taking place there?
The event on Tuesday is a public awareness forum. It's geared to educate, it's geared to provide some insight into the concept of smart grids globally and what's happening in Trinidad and Tobago, what are our challenges, what are the benefits, and ensure that the public who attends can really get a feel for what's going to happen in the next coming years and where we need to be in terms of when you look at a particular appliance, when you read about smart grid, smart city, you know what that means and you will have an idea of where Trinidad and Tobago is going to be in the next few years. We need to think like that, and we need to ensure that everyone is on board for that.
Because right now, I mean, you see people in stores buying appliances, for example, and the one thing they don't look at is the energy.
Yeah, that's correct.
And in other countries, that's the first thing they look at because they want to know how much it'll cost them.
That goes back to the fundamental issue we discussed. We're blessed
with an abundance, which has made us lazy and sloppy in how we consume power.
Correct. So we need to change that, and we need to be environmentally conscious. We need to be more energy efficient, and it's going to happen. It's going to happen, but it's going to be with public awareness. We're going to have to ensure that there are alternate sources of energy that can be employed, as well as there's the economic impact is going to be very. We need to ensure that whether we can do that while satisfying all the other goals, that's a challenge. But we need to be conscious of that. So our decisions forward are going to be very strategic.
Now, to get any sort of movement in that direction, I would imagine you need sort of government fully on board.
Yeah, we definitely need government fully on board.
Are they fully on board at this point?
Well, that's a very tricky question, and I can't say.
Mm-hmm.
I'm not placed in the government, but I do know that the government has made initial steps to ensuring that we have produced the Wind Resource Atlas, so they are very conscious about integrating renewable power into the grid. However, there's baby steps. Mm-hmm. And we still need to make some other infrastructural changes, some legislation to ensure that the complementary initiatives are very much aligned with where we should be going, and we are technically on the right path. So I do believe the government is on board with this, and perhaps as things change a bit, the market continues to expand, we will be seeing some changes from.
But you almost need the government to sort of come out and say, listen, we have a 10-year plan to get to this point, whatever that point that we choose to be, and therefore here are the steps we're taking.
Yes.
Just giving a commitment doesn't really help, does it?
Correct. We need a plan, and on the talk on Thursday, that's actually one of the key points that I've put in there. We need to plan. We need to plan. We need to plan. We need to have a roadmap. We need to ensure that Trinidad and Tobago is strategically positioned. We know where we are now. We know where we are going, and we have a path that we need to follow. And we need all our stakeholders on board: government, private sector, the consumers, or advocacy, what do you call them? The environmental groups. We need to get them on board. So we need to get everyone hands on deck.
Now, the public awareness event, anybody can just show up, is that it?
Correct.
And where exactly is it?
It's open to the public from 2 to 4 p.m. at the Noor Hassan Ali Auditorium. Mm-hmm. It is located at the Faculty of Law, which is immediately north of the Faculty of Natural Sciences.
And you're thinking in your own mind now, if you get public awareness of the building up, if you get government on board, what kind of time frame are you thinking we'll start seeing some major progress towards having a smart grid?
Well, progress is all relative.
Yep.
We are already progressing, right? But in terms of the incremental changes that can define the actual value of the smart grid, we are looking at realistically in about a 5 to 10 year period.
That quick?
That quick. We can do it. We can do it.
But you know, we're a country famous for sort of sitting on things until it's absolutely the last possible moment and things are about to fall apart.
Yeah, that is true. But you know what? With the correct minds involved, the correct willpower, and a collaborative force between all these stakeholders, we have academia on board, we're going to get the governments on board, we're going to get private sector, get our consumers, it can be done. We need to be positive about it, and we need to ensure that we can work towards it.
Well, and I guess one thing would be if power rates actually were similar to other parts of the Caribbean, we'd really get ourselves in gear at that point, wouldn't we?
That's going to be another revolution.
That would hurt us all as well. So.
Yes, it would. Yes, it would.
Well, Sanjay Bahadoorsingh, it's been a pleasure having you on the program. I feel I've learned a lot about stuff I didn't know anything about at all before, so that makes you a very good UE lecturer.
I appreciate that. Thank you very much.
Thank you very much for being here. It's a great pleasure having you.
Care.
Thank you. You've been watching
Bye-bye.
One-on-One. Join us again tomorrow for another edition.